Alright, this lesson is designed to teach you how to find the mean and the standard deviation from a frequency chart, such as this one. Now, first I need to remind you what a frequency chart is and how it works. So, it's all about these numbers down here at the bottom. This graph is telling you about flight delays. This information is the number of minutes each flight was delayed for Nova Scotia Airways during a certain period of time. So, each one of these squares represents a flight, but where it is tells you how many minutes it was delayed. So, in other words, look at the numbers at the bottom. See this? See this 0? That means this flight was delayed 0 minutes. Same with this one. This is a 1. So that means this flight was delayed 1 minute. These 4 flights were delayed 1 minute. These 5 flights were all delayed 2 minutes. These 7 flights were all delayed 3 minutes. And so on. Now, my goal is to use the TI-30 XS multiview in order to show you how to find the mean and the standard deviation. I would recommend resetting the calculator, which I'm going to do right now. Hit your data button. Now understand this. If I had all the time in the world, I could just type these numbers in one at a time. There are 42 numbers here. So if I were going to do this like I've done in the past, then I would just start typing 0, 0, 1, 1, 1, 1, 2, 2, 2, 2, 2, and so on. I would keep typing until I typed in all of the numbers represented by this graph. And once those numbers were in, if I wanted to find the mean and the standard deviation, I could go second stat, hit enter. The data's in L1, so I could hit enter a few times. And then this number, the X bar, would be my mean. I could scroll down a little bit. This number would be my standard deviation. Now these numbers are totally wrong because I only typed in a few numbers. I didn't type in all 42. But that would be foolish of me. It's set up as a frequency table. There are several 1s, many 2s, many 3s, many 4s. So rather than typing in all the numbers individually, the TI-30 will allow me to make a frequency table. Also, I should mention that the TI-30 list will only handle 40 numbers. So this has 42, so that's too many anyway. So I actually would not be able to type them all in because they're just too many. So here's what you do instead. Instead of typing in all the numbers, we will make a frequency chart by simply typing in one of each number. So we will just type in 0, 1, 2, 3, 4, 5, 6, 7, and 8. Just type in one of each number. Okay, so let me just clear this out real quick. So 0, 1, 2, 3, 4, 5, 6, 7, and 8. I typed in one of each number. Now, this is going to be a frequency chart. So, in the second column, I'm going to put the frequency, how many of each number there are. So, there were 2 zeros, so I will put a 2. There were 4 1s. So for the 1s, I'm going to put a 4. How many 2s were there? I believe there were 5. Okay, there were 5 2s. Okay, then there were 7 3s and 8 4s. Okay, so there are 7 3s and there are 8 4s. Now I seem to remember some symmetry happening. So then it goes 7 of these, 5, 4 of these. Okay, so there's 7 of these, 5 of these, 4 of these, and 2 of these. So this is a frequency chart. We have our data in the first column, but then we have the frequency, how many of each we have in the second column. So your calculator will understand this if you do it just right. So if I want to find the mean and the standard deviation, I will do second stat, second, and then hit the data button as I have before. I still want one variable, statistics, so I will hit enter. Now here I have to be careful. See this FRQ? That stands for frequency. In the past, we haven't had frequencies, so we just left this at 1. Everything just occurred one time. But because now we're supposed to understand that everything in list 1 has a frequency listed in list 2, we have to change this. So we will go down to the frequency line, and we will go to the list where we kept the frequencies. So that's L2. And hit enter. So now the calculator understands the data is in L1, the frequencies are in L2. And your calculator knows just what to do. If you hit enter now, look, first of all, notice this N tells you how many data elements you have. Normally, if we type in 9 numbers in list 1, this would say 9. But it says 44 instead. That's because it is using those frequencies and it understands that there are 4 numbers that we're dealing with. There are 44 numbers that we are dealing with. And here's the mean, x bar. So the mean is 4. So we can go ahead and write that down right now. The mean is 4, you guys. What about the standard deviation? I can't wait. Let's scroll down. Here is the standard deviation, item 4. It is 2.08. I'll round it to 2.08. So that is how you use your TI-30 to find the mean and the standard deviation from a frequency table. Let me mention one more thing. Very often the data will be perfectly symmetric. See the balance? Here we have our middle column like this, but then to the left and right it's 7 and 7, 5 and 5, 4 and 4, 2 and 2. It's perfectly balanced. Whenever that happens, the mean and the median will be the middle number. So that's going to be 4. So like, for example, at a glance, if you look at problem number 2, you know that the middle of this distribution is 7. So you know the mean is going to be 7 without even typing it in. While I'm showing you this picture, really quickly, let me mention something to you. If I want to make a frequency table with this, see how there's a gap right here? The 6, the 7, the 8 are missing. You still need to include these numbers, okay? So when I make my frequency tables, and I'm just going to reset my calculator again. So hit data. Looking at this chart, it starts at 0, it ends at 14. I'm going to include the numbers in the middle, okay? So what I have is it goes from 0 all the way to 14. So I'm going to do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I typed in those numbers in the middle, even though there's nothing there. That's fine. Just when I get to those numbers, just understand the frequency of these will be 0. So this it's going 7. There's 7 of these, 5 of these, 3 of these. So 7, 5, 3, 2, 1. Okay, so it's going to go 7, 5, 3, 2, 1. All right, so that brings me up to the 5. And there's one of those as well. Now, 6, 7, and 8 are the ones that are blank. There are none of them, so that's 0, a frequency of 0. So I will simply put 0 for 6, 7, and 8. Now, back with 9, I remember the symmetry, so this will be 1 and 1. And here I am at 11. So that's going to be, it's going to go 2, 3, 5, 7. So 2, 3, 5, 7. Okay, so again, I can now do second data or second stat. Hit enter for one variable statistics. This is fine, but the frequency, once again, I put frequencies in the second list. So I have to highlight this and hit enter again. So this list had 38 numbers. That means I could have typed them all in the calculator manually if I wanted to, but who has the time for that? Notice that the mean is 7, which we already knew because it's in the middle and it's symmetric. It's perfectly balanced. Now the standard deviation. Scrolling down, I see that the standard deviation is 5.82. So let's write that down. So the standard deviation is 5.82. All right, that is how you use the TI-30 to find the mean and the standard deviation from a frequency table. All right, I'm going to go ahead and do a little extra information. Just in terms of if you wanted to do a comparison between Nova Scotia Airways and Alaska Airways. Looking at their means, Nova Scotia Airways had a mean delay time of 4. Alaska Airways had a delay time of 7. So, if I want to compare these, I'm going to do this in sort of like a paragraph. So first I'm going to make my first sentence like this. Alaska Air, you know what, I'm going to type it in off camera. When you're making this comparison, I think it's good to state the basic information, who has the higher mean, and then say what that means, what is the significance. So I would say this, Alaska Air has a higher mean, the 7 versus the 4 minutes. This means Alaska Air usually has longer delays. So that's those are the two statements I could make about the mean. Now here are two statements I could make about the standard deviation. First of all, who had the higher standard deviation? Okay, Alaska had the higher standard deviation also. So here are the statements that you could make about the standard deviation. Alaska Air has a higher standard deviation of 5.82 versus 2.08 minutes. This means that the length of Alaska Air delays varies more. All right, there's more variety in the length of the delay. You could have just as easily said it the other way and said that Nova Scotia Air had the lower standard deviation. If you go with that, then you're going to say this means that Nova Scotia delays are more consistent length. All right, that is the end of this video. I hope now you understand how to use your TI-30 XS Multiview to find the mean and standard deviation of a frequency table.